In this video, you'll learn about solving a system of equations by graphing. The definition of a system of equations is that it is a set of two or more equations that use the same variables. In order to solve a system by graphing, you have to follow the following steps. First, you would solve each equation for y so that it is in y equals mx plus b form. Then graph the first line by plotting the b value on the y-axis. Then use the slope, rise over run, to plot several more points, making sure that you extend your line in both directions. Then graph the second line the same way, and finally find the intersection point. This is the solution to the system, and you're going to write your solution as an ordered pair, or x comma y. In our first example, we're going to graph the two lines separately. So our first example is y equals 2x, which is really 2x plus 0. So our slope is 2 over 1, and our y-intercept is 0. So I can plot my point at 0 on the y-axis, go up 2 and over 1, and then draw in the line. Now for the next equation, we're going to follow the same process. So our slope is negative 1 over 1, and our y-intercept is 6. So I'm going to graph my point at 6 on the y-axis, graph another point using the slope, and then draw in the line. Now the intersection of these two lines is the solution to the system. So when you finish, in order to finish answering the question, you need to write that the solution, and in this case it would be at, our ordered pair would be 2 comma 4. Pause the video and try the next one on your own. Now, in order to graph the first equation, we can first identify that our slope is negative 3 over 4, and our y-intercept is 1. So I can plot my point on the y-axis, go down 3 and over 4, and draw in the line. For the next equation, we're going to follow the same process. So our slope is 1 over 2, and our y-intercept is negative 4. So I can plot a point at the y-intercept, go up 1 and over 2, and then draw in the line. Now the intersection of the two lines is the solution to the system. So the solution for this system would be at 4 comma negative 2. Next, we have to talk about special cases of systems of equations. There's two different special cases that we may have. The first type of special case is called infinitely many solutions, and the reason is that it results in only one line. So as we see here, there's two equations graphed, but both of these equations are the exact same, so it's infinitely many solutions because they intersect in an infinite number of locations. The next type of special case we have is called no solution, and this is because the line, it results in parallel lines, and what we know about parallel lines is that they never intersect. So if I look at these two lines, they're both going to continue forever and ever and never cross, so we don't have a solution to choose. So for this example, we are again going to solve by graphing each equation separately. So for the first equation, my slope is the 5 over 3, and the y-intercept is the value of negative 1. So I can start by graphing my y-intercept. So I can put a point at negative 1, and then because it's 5 over 3, I'm going to go up 5 and over 3. So if I count to go up 5 and then over 3, I could put my point right here. And then this would allow me to draw in my line. Now for the next equation, I have a slope of 5 over 3 and a y-intercept of -4. So I can start by putting a point at -4 on the y-axis, and then I would go up 5 and over 3. So if I count up 5 places and then over 3, I'm going to have a point right here. So I can put my point on the graph. And now this allows me to draw in my line. Now what we can see is that these lines are parallel and are going to continue forever and ever and never cross. So this is what we call no solution.